the topic today start with object-oriented concept. Actually, we all do object-oriented in programming or doing the software, but it's essential that the people should know how to apply the concept after they know the concept with our programming. So let's go to see what is the topic is all about. Actually, what you need to do is only four of the concept that cover almost everything in object oriented. However, throughout the class, in order to make the programming the code to work in the productivity level, you need to have another tools, that we gonna do it later. So today we gonna just cover the concept. That is, the first one is about class and instance. Some textbook may call instantiate, and then it's encapsulation, inheritance, and polymorphism. Okay, so we can start with the object-oriented programming concept. Okay, so let's start. When we talking about the object-oriented concept, is on about the way we see the world, because the computer system or the another system, they have no matter which kind of system you are using, you may use it in your mobile phone or even you play the game. Actually, it is the simulated, like it is simulation for the real world object. Okay, so we're gonna have the class of instance. That is the first thing you need to know. And then another key thing that we call three pillars of object-oriented, that is encapsulation, inheritance, and polymorphism. Okay, let's see about class and instance. Okay, we're talking about the system, right? When we create the computer software, it means we are creating the system. The system is the environment that the entity can be anything. For example, in the university realm, the entity can be student, like the course that you enroll, that is the entity, right? Every time you get the grade is entity as well. When we do the business, it is essential for the people to extract the entity that we need in the system. And then instance is the representation of an entity, and class is the blueprint of an entity. In object-oriented concept, it means you create class first, and then after you create class, you can create instance. All the instances in the system must belong to a class. You cannot just have instance pop up from nowhere. You need to have the class. So all the instance must have the same set of attributes, but different for you. So let's see, when we are talking about the student. The student supposed to have student ID, first name and last name, right? We didn't need to care whether the value inside gonna be different, because of course it's gonna be different. For example, the student ID, no one gonna have the same ID, right? It's unique, right? But the student ID should have the rule. For example, in the university, the student ID must have 7 digits. Something like that. Everyone have the first name and last name, right? Sometimes the people may have middle name, but that is not the case. Something like this. But anyways, everyone need to have name. We cannot just have ID. We need to have name, right? And then another property or another attributes can be something like the major, the faculty that you belong to, right? For the student, we call school, right? The school, you may belong to school of business, school of engineering, school of communication art, whatever. In the theory, the number of instance equal to number of entities in the real world, right? Suppose we have the student class, and then we may have the support. We have 1,000 students in the university, so we should have 1,000 instance. But actually, the computer program will represent only the instance that the program is interacting. When we write the computer program or when we use it, we just use only one by one, right? When you use the program to do the registration, like your program didn't need to have 1,000, 10,000 students in the program. They just have only one student represent in the program, that is you, right? When we play the game too, you see the game will not have on off the character or label. They just have the character that is surrounding that the one that they're gonna interact with, the main character, something like that. Okay, so for example นะครับ the problem domain นะครับ this one is maybe a little bit out topic นะครับ problem domain is mean this one supposed to be in the software engineering or information system analysis or and design, right? But okay, let's talk about the problem domain that is the university registration system. So the entity can be student. Student need to enroll with a section, and then section belong to the course, and then course belong to the lecturer. The other entity can be room, examination schedule, right? Actually this one is a time slot, and then the examination itself, because every time you go to examination room and then you sign the name, right? So what is the result? The result going to be the score you have, and then the score going to become later on become the grade. So the characteristic of the class that we call the attribute, actually in the textbook they may have something like class attribute, instant attribute, but for the system design we didn't need to go to that level. So we just said instant attribute that is belong to instant. So for example, your student ID is a number that representing your entity. So you didn't need to care about the other. And then we could have the behavior. In the system design we call action, but for the computer programming, most of the time we call method like Java method. But in the Python we call function. We call function. Some textbook gonna call method as well. But anyway, it's the same thing. So they gonna perform some execution. I mean, when you do the behavior, right? I mean, everything in the world cannot change the state, cannot evolve by themselves, right? I mean, they must have some action, you know. I mean, you even though you may think that in the biology, the creature they just grow up, right? But you cannot just grow up. Every day you need to breathe, right? You need to eat the food, right? Or else you cannot grow up. So the behavior can do some execution and they can transfer the value. Actually, the computer program is just only do this, I mean, they have some execution, they have some mathematical calculation, or they may have some interact with the hardware, right? And then transfer. So that is the class characteristic. And then we have the word we call composition. Composition is a terminology that one object is an attribute of other object. For example, if you say the student enrolled the section, right? Section itself can be another object. So it's possible. Okay. Next, so when we're talking about the student card, we have the attribute, student ID, first name, last name, the student credits earned and GPA. Actually, credit earned and GPA is quite interesting, but we will not talk about this one in the detail right now. This one we're gonna have this thing in transaction, but in transaction we will not use the university. We're gonna use the the payments gateway system. But the concept is the same thing. Is that this attribute actually is not existing in the database. It's come from the calculation. And then the behavior is mean the action that the class or the object can do, right? For the student can enroll. The student can take examination. In most of the programming language, we gonna use the open and close bracket is the statement is to tell the people that we are gonna do function or method. So behavior is when we're gonna use the open and close bracket at the end, right? Sometimes you can put the argument, right? I mean the list of the argument or the list of parameter you can put in, but for the design we can just put open and close bracket. That is more than enough. Okay, so in the object-oriented, we have class diagram, and then you see we're gonna do something similar to several rectangle, but with the curved corner. This one we call class diagram. That's gonna have the class name and then the list of the attribute and the list of behavior. So class diagram is just like this. We have the class name, we have the attribute, the minus and plus sign we're going to see in the topic of encapsulation, and then behavior. I mean, if you want to make it detailed, like you need to put parameter in all of them, but actually you no need to do that one because it's gonna make class diagram. I mean the entity is go too big, so we just use open and close bracket. With object-oriented approach, the set of diagram that we use it to describe the system. However, most of the diagram is to do the system design, and then when we do the coding, we gonna use the design and then do the action in the coding นะครับ so we have the class diagram so we can see นะครับ in week นะครับ this one is the example of the class diagram you see yes you see นะครับ it's gonna be similar to something that you may learn in database called that is the ER diagram entity relationship yes actually we do the relational class diagram to we cannot say replace because sometimes we need to create both ER diagram and class diagram but if you did not use something like the database oriented approach class diagram is actually is more than enough more than enough to do it you do not need to have the ER diagram but you may need ER diagram in case that you need to exercise SQL okay but that is not the that is not the topic in this course anyway next one is the use case diagram use case diagram is the one who gonna apply with the uh, business requirement business requirement so the use case diagram is like this we're gonna have actor right most of the time the actor is gonna be the people but sometimes the actor can be another system the actor is mean the one who gonna interact and then when they interact they're gonna have the action right so when we do the use case diagram, we gonna decide whether the actor what is the behavior they do, and then this behavior is belong to which module. So when we write the computer programming, we gonna know that we need to write the code in this module, and then this module must come from the class diagram. You see, so when we have the class, we have the action. So it's on gonna related. However, the actor and then the use case, right? This one called use case นะครับ The action or the use case is due to the business requirement นะครับ You can talk about something like public attribute actually there is no such thing like public attribute let's say public action right private attribute to the business user right it's not going to make any sense นะครับ so that's why maybe we use the use case to do นะครับ and then the use case itself maybe they're gonna tell you what you're gonna do but they didn't tell you how to do it นะครับ so that's why we have activity diagram so the activity diagram tell you exactly how to do it so when you write the code นะครับ in we write the code in maybe Java maybe Python or any action นะครับ the code itself they're gonna have uh, they're gonna have the activity diagram นะครับ and then sometimes we're gonna call the swim lane นะฮะ to see this one so you see they're gonna have this one so when we call swim lane because we have different actor right and then they're gonna have the action inside this one so the action inside is maybe this is a little bit in detail นะครับ so you need to make sure that you can change what is written here to become the code นี่นะครับ so when you set insert card how can the program know that the card is inserted already from the machine right and then accept the pin right นะครับ and then the pin gonna send to the bank and then check whether is correct or not blah 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 so you see this one three of them is more than enough นะครับ and then three of them must come from the concept of the class you see so just only the concept of the class that we have the attribute and action we can use this one นะครับ however in our course we may not go into the detail this one is the software engineering in the information system and design topic นะครับ okay so this one for the class and instance this one is gonna be the one that I can tell you นะครับ It is normal to spend the time on designing and study the system on the paper นะครับ more than actual coding I mean suppose you have 3 months to do the work right actually you're supposed to do the paperwork for 2 months นะครับ I mean you need to design until you know exactly what to do and then you do start coding นะครับ I mean when we do the enterprise system we should do something like this